we're getting a new space in the Bartlett, and over the next couple of years, we're going to be up the road. Sorry, Bob Shield and Kevin have just had a massive problem with the water jet cutter. What do you do with big space? Well, one of the things I'm going to be trying to probe here is to try and put together everything that's been going on across the panel and perhaps across the session, and to make some propositions about smart geometry. And thanks very much to Hugh, actually, for a bit of a talk last night about what he felt the real thing was. And that was, there's no such thing as smart in terms of geometry, or cities, or buildings. It's people that are smart. And what smart geometry is about people. It's not about technology, which is sort of what we thought it was going to be about back in 2000. We thought there's all this new computing technology, great opportunities. No, what smart geometry is actually about sociology. And so what's really fascinating about this conference as it has matured over the years is what takes place around the conference. It's the workshops that are going on or have been going on all week. It's the several weeks of work that people have online before the workshops where they get everything prepared and work out what they're going to do and start coding early so that they're already up and running when they arrive. And then it's what you do when you get into the space of the building, you get everybody together, you realize the virtual community in real space, and you make something happen. And it's really that has been successful over the last 10 years of smart geometry. Now, I'm going to make an argument. It's a very long-term argument. And I'm referring back to somebody called Korotayev, Andrea Korotayev, who's been looking at the long history of cities and the evolution of city-states. And he goes way back. He actually goes back further than this, which goes back to sort of 1000 BC, to look at the size of settlements, the size of megacities of the time, and the size of states. And what he finds is that every time the carrying capacity of the city increases, scales up, the carrying capacity of the whole state scales up along with it. You get periods where everything remains the same, and then there's usually a technological breakthrough, the invention of something, maybe it's an irrigation system, that allows the whole thing to upscale. And then you get a leap. Now, I think what's happening at the moment is we're in the middle of a leap. And we're in the middle of a leap because of information technology and what that enables. The question is, what will that do to the politics? What will that do to the structure of cities? Will cities get triple the size that they are at the moment, or 10 times the size they are at the moment? Well, it looks like that's happening. You only have to look at the size of cities in Pearl River Delta, all agglomerating into a single 60 million person city, and you've got it happening. So all of that's happening on the basis of new technology, which allows transportation, communication, and people to engage together. And if we're going through that next transition, what does that mean? Well, it's very interesting if you look at the role of architecture in this process. This is a little sample of Greek temples, and they're actually from the early days of the Greek civilization. It's when we think of a Greek temple as being that thing with a pediment on it and a set of columns and so forth, an absolutely fixed type. In fact, when they first emerged, they tried all sorts. They had circular ones, they had ones with 3 sets of columns, they had ones with 2 ends, ones with 1 end, and so forth. And every one of these is an experiment. You get, if you like, a protozoan explosion of different types, looking for the genotype. Then, when the Greek Empire expands around the rest of the world, it's the one type that gets reproduced. And that's a single entity. So, I'm interested in evolution. I'm interested in the evolution of design practice itself. And I'm going to make a set of suggestions. Architectural practices operate in a market, fairly obvious. They seek to brand themselves. They seek to say, we are one of these. We are a particular kind of thing. And then they seek to differentiate themselves from each other. And that creates a dynamic system. By differentiating, they do things like they have an ethic. We've heard the first Co-op X here with a very powerful ethical position about doing good for the poor of the world. There are others who may have an ethic that says we are frontline commercial architects doing commercial bidding of our major clients. Those are ethical positions, and they're ones that you take. People have aesthetic positions. They mark themselves out according to a particular color of gray that they always put onto their particular aluminium. Or they have a particular approach to how decorated or undecorated the building should be. And people mark themselves out and differentiate themselves according to their processes. Every architectural practice that I can think of thinks that it has a unique and wonderful process and prides itself on the development of that process and on differentiating itself from others and saying, we do it, come and buy us because we are better than them because our process is better. Now, ethics and process is where scientific theory comes in. And I think it's really important. If you can predict the outcomes of something and build the better building for some outcome, then you have an ethical duty to make sure that you do that. So long as we can predict outcomes, then you can get it better. So Judith's wonderful work that suggests that our predictions are completely up the spout when it comes to energy utilization are really meaningful. It's no good just relying on the physics modeling of your building to predict how its energy utilization is going to take place and saying we have a wonderful process because we've used this physics model. The data don't support it. Go back and look at the meter. Yeah? They're all using double the amount of electricity that was predicted. There's also a process dimension to working in this way. So as soon as you start learning from actuality to feed back into critically evolve your design, then you're into a new kind of process, and it's a process with feedbacks in it. Now, there's another group of people out there who are the architectural critics and the media, the people who, if you like, create the milieu within which we all operate. Tremendously important for architectural innovation. We sit there and we listen to them, we read the magazines, we look at the blogs, and we try to understand what it is that we are positioning ourselves in terms of. Sometimes it's, I want to be like one of those, that's a good idea. Sometimes it's, I want to distinguish myself from those guys over there, I've got a completely different position, I want to be over there. These critics publish these wonderful works, yeah? But what I'm going to suggest is that we're a bit like this. There are star-architects, series of star-architects. They go off in various directions. They make new things. Sometimes they converge. Quite often they diverge. Then there's all the other ones, the squares, who go around and want to emulate. And they flock together and say, I want to be one of those. I like that stuff. Yeah? So what's it really like? Well, it's like one of these things. This is a murmuration of starlings. It's a flocking according to who knows what rules. It's the rules by which birds fly around. Sometimes they divide into two flocks. Sometimes they come back together and merge again. What's always happening is those on the outside edge, at the front leading edge, are setting the direction. And those behind are always following. It's a fascinating phenomenon. Now, I'm going to suggest that what's going on in smart geometry and in all the other architectural milieu of innovation, actually, not just this conference, but the other places where this takes place around the world, is that we're doing that. We're exploring the problem space. We get together regularly, every year, every 2 years in this sort of group, and we exchange ideas. We look at ideas to copy and to emulate. We try to differentiate because we've spotted something that somebody else hasn't spotted. And in doing that, we're constructing a social grouping in which we're going to evolve. Tie this back now to Generative. We're doing this with new technologies, whether it's computational technologies and scripting embedded in our drawing software, whether it's the use of robots to manufacture and to make stuff, whether it is the way that all of those knit together into the social group of the construction industry, its clients, its financiers, and the technology companies, the Intels of the world that are providing the chips that make it all happen. All of that dynamics is one which is an ongoing evolutionary dynamics which we need to understand. And we need to understand its anthropology because we're working inside it. It's a bit like being in the flock of starlings. We can see the amazing beauty of that swarm effect, but only because we're standing outside it. If you were a starling inside that, you would just see lots of other starlings around you, and you'd be madly fighting to know which direction to go next and trying to avoid collisions. That, I suspect, is what we're all doing every day, but from time to time you want to stand back outside the flock. Okay? Let's have a discussion.
Oh, I've got a good question. Does it work? Oh, brilliant. There was one thing I didn't say after the simulation with that showed the bike, the shortest routes between the cycle docking stations. And the reason, well, we did an estimate of how much carbon we're saving by cycling, and it is based on assumptions. But if you compare the amount of carbon it would take to take all those journeys with a mixture of taxis, buses, etc., over a year, the equivalent of how many 10-story office buildings in London would emit that much carbon. Does that make sense, the question?
Yes.
So, votes, hands up, anyone above 50? Anybody above 20? A few hands. Anybody above 10? Anybody above 5? The others are. Anybody 2? 1, 2? Yeah, you're right. Oh, they've done the homework. So I think it's, from my perspective, I think that we as architects don't really understand carbon and energy consumption. We're not really literate enough to have informed conversations with consultants about it. It's not really well, the question was about whether the audience knew the answers.
So related to that then, I guess this is probably a question for me around starlings and facilities managers, who are kind of the same kinds of beasts in some ways. So I spent about 10 years in my previous job trying to understand workplace performance and how much energy was being used, and all of that was around trying to create interfaces that would try and encourage behavioural change around less energy use. So it was a bit of a mix of, actually no, it was focused on trying to nudge behaviours in a certain direction. And I guess one of the things that you do learn, which I think your work does sort of back up, is that actually, largely it was always one person that we needed to nudge to basically set up and run the building better, as opposed to trying to get everybody in the room to try and behave in different ways. And so kind of related to that was this issue of how do you start to affect that behavioural change? So making the data open, which I think is the great thing about Carbon Buzz, I think that's exactly the right direction. I like the comment that Alan made to me before the session around, it's like with the National Air Traffic thing where you have there is a culture of reporting near misses, and I guess it's probably regulated as well that they have to report those. There's an element of regulation there as well, but there is that kind of culture of sharing where things are going wrong, because the industry as a whole knows it's going to be beneficial. So how do we move this sector into a position where actually everyone will start to share the kind of information that you're looking at? Because the reality is that it's not really being done at the moment, I don't think.
I will even like to argue that if my data is correct, so that the 10% of this world is being designed, so the design that we see and we experience because we are here, and the 90% is not, how can we control this sprawling of cities? Because we're talking about making the city of the future, we're talking about cities are growing, but we need to calculate the cities are growing, especially in developing countries. How can we calculate data when the design is informal or is intuitive? I mean, there is no control besides necessities.
I think this is a very interesting point. I mean, the other point I would make is if you look at the per capita carbon consumption of your favelas in Salvador, my bet is they're going to be well lower than the per capita carbon consumption in Dubai.
think it's a very interesting point, and when I said carbon bus was disruptive technology, I think the only recognition that we had is any individual, based on your beautiful Starling animation, any individual wants to know is where they sit in the flock. So where is my building compared to anybody else's? And if you make that information available, so a contractor will only want to know whether he's going to be penalized at the end of the contract if he doesn't hit the targets. Without that, he thinks it's just a talk shop, really, to do soft landings. but so I think the way it is about incentivizing the individuals in the Starling flock and make sure they feel that there is something. I think Usman was saying similar things earlier.
Yeah, I mean, what I wanted to say, or what I found very interesting actually in the different presentations and the discussion, it's just kind of starting, is that there are kind of two very different approaches, not necessarily seemingly different. Let's say, one is very much based on individuals and on like sociological and behavioral phenomena and how you deal with them, and the other one is more about kind of technological kind of advances and how you share data and how you use that, or the other one to basically tackle the challenges that the mega cities of today and the future kind of face. And it's kind of become a cliche to say that in 2050, 75% or something are going to be living in cities. Everybody says it all the time, but I'm wondering kind of how you can combine these two approaches. And I think right now we're kind of failing really to formulate a theory of how to deal with these issues, right? And well, I'm just wondering what the kind of potential ways of combining data and sociological, behavioral, and social kind of strategies are, and how we can achieve that.
I thought this triangle between Cristina, Judit, and Alan was interesting because if we look at that 90-10 divide and how little we might be able to influence, and where even though there might be right now a different level in energy usage and water usage and all resource usage in general. I don't think that we, in the long run, can prevent those people from wanting to enjoy the same levels of comfort and so on that we enjoy. So there will also be the biggest growth in resource usage in those areas where there is almost no design or no design. So I think there is a big challenge, and yeah, I wonder whether that just shakes out the way it shakes out, right? If we look back at the history of how our societies developed, there were periods of probably that same 10-90% design, no design as well. And it eventually turned into being all regulated and all about being designed, right? I'm not sure whether from our perspective, and being scared as we might be of what is going to happen, whether we can accelerate that learning process or that development process. And maybe it's not even the best learning process to begin with.
Cristina.
Well, I think that this good, smart practicing the design in developing country could be enhanced by perhaps open sources, right? Like the open source of the school experience being shared in a platform, in an open data platform. That would be interesting to implement in such country, in developing countries. But then I wonder which kind of language should we be using? Because right now what we have experienced is that we are doing participatory workshops. These are very, very difficult because physically you have to be there. You have to gather people, you have to gather the stakeholders, people that can really make decisions. And it's still a bit top-down imposition. Who has the capital invites us over, we do the workshop, we do the trick, and we have something done. What would be really nice is to share information in a different way, that we don't have to be there, we don't have to go there physically, but these workshops can happen virtually. I don't know if this is possible in the future cities. And which kind of language are we going to be using? Not only spoken language, but really, electronic language.
Yes, that also comes back to the kind of the socio-technical point as well. I think it's to me this is a very this is a problem that's close to my heart with the schools project. There's 22,000 schools in the UK, and we're working with 8 over the next year. And that working with 8 is a very pragmatic situation where, you know, we need to go in. It's a participatory design process. The school kids and teachers are going to be designing the instruments that they're going to be putting into the schools, so that they can then take ownership of those and the data that's created, and that can become part of the curriculum material that they're using. So it's just the way that we have to do it. But the last quarter of that project is very much about saying, okay, so how do we now scale this? You know, how can we start to sustain these systems so that actually other people can pick up components of what we've been trying to create and go and run with it freely? And so this is where, I think on my last slide, I didn't talk about it, but there was a second bullet which was about kind of letting go and serendipity, which to me is energy data as well. Every energy data that I've created, I've been asked by my employers to not share publicly. When you ask them why, it's kind of, I don't know, it might be useful. And so there are these kind of very real issues around sharing data, but I think that's where we have to be doing it. And this to me is why the socio-technical, if you like, you were describing them as 2 separate activities. And I think that there's, you know, within the whole smart city arena, I think there's lots of great examples of where the technology solutions, don't know what the problems were, but the technology solutions haven't worked. And so you can't do them separate. It has to be the 2 of them if you're wanting to do things at scale. You know, I would argue that you can't, you know, at the end of this project, we might have had success that we've got 8 schools working. That's not really a success if there's only 8 working. You know, Carbon Buzz is not, I would argue, it's not really successful if only Aedas are using it. You know, fantastic. But you get the point, though. You know, it is when these things start to scale up, that's when they start to show the value, and that's the challenge of combining those 2 things together.
Look, I want to open this up to the floor. It seems to me that there's something really quite interesting that's emerging in the debate, and that is that the openness of data, the access to data, and Usman made the point about working with data, getting people to actually participate through doing the measurement, doing the data capture themselves, and therefore I think, reversing the power relationship. Previously, access to data has always been power. Now, technology makes it possible for one to be gathering that data oneself and to be contributing it into the common good. That seems to me to be the real radical power restructuring that will be taking place in the new society, whatever that is. It will be one in which open data is partly open data from government sources and big industry and so forth, making their data available under pressure. But it will be partly because those data are themselves being gathered primarily by individual members of the public. That is a big common and political activity, which I think will have a very disruptive effect. I'm just wondering if there are any thoughts from the floor either about that or from other aspects.
We'll bring you a microphone, just 1 second.
When it comes to open data, I think you have a classic example here in the UK with your Ordnance Survey, trying to open their data that's making mapping data available to most of the citizens. So you see some of the issues involved in that particular case. But one of the things I found interesting was when Judit was talking, and Duncan perhaps might answer this, is what is the difference between the wireless sensors and those sensors that are connected, and how do they influence design? In other words, as we say, we want more data to have better performance and optimization. Is it a case of some buildings might not be able to be sensed due to the kinds of sensors? It makes them too expensive, perhaps, or there's not computing available.
So I've got quite a simple take on that, which is that technically everything's possible. It tends to be the economic barrier that is what actually defines what happens. So we've got plenty of different ways of different radio devices, through from the Wi-Fi we use in this room through to things like Zigbee, which is an emerging standard. You've got companies like there's an Intel VC-supported firm in France called Sigfox, which are basically putting out a low-cost equivalent to GSM. So rather than having to use a phone chip to upload data to the cellular network, they've got a very small, low-cost device that allows you to do it for pennies. So where a phone is too expensive and the data rate of a phone is too expensive, you could use that kind of platform. Within 18 months, they've got 60% of France covered already. So I always find there's technological solutions to these things. The barrier that I always see is just the cost equation. So one of the research projects in our institute is around this idea of data muling. So it's taking this notion that within cities there's lots of things that move around, cars, people. So why not use those things that are moving around anyway to transport some data for you? I've got a computer here that I'm carrying around. I could be relaying data about this building back to a base station if maybe I got a couple of free minutes on my phone contract. So it's the economic models to me which are the interesting bit.
I have a non-question myself here. I would like to address this to you, Judit. I was really happy to hear your lecture on, and I think it's the first one I've ever heard so far, which is about extensively talking about documenting all these things, all this construct that we do, which is simulation of smart buildings, smart energy management, and actually going back to those buildings and getting the live input and the feedback and the results of what we have designed. I think that's amazing. But I was wondering, because I can also put myself in the perspective of other people, non-designers, and maybe not understand the necessity to actually document the actual implementation of those simulations, because I can really easily see either the client or maybe people from your own company itself going and asking like, why are you going to go and get data from your building? What's wrong with the design? Isn't it okay? Is there something wrong? Right? So I was wondering if you have ever confronted that situation of needing to address why you want to go and capture back data of what you have designed.
It's a really good question, and I was thinking when Alan was talking about the impact of these bottom-up kind of movements or initiatives or projects, and I was thinking, well, actually, if I really think about it, top-down approach is so effective sometimes, and I just we're doing a lot of work because, for example, in the UK, display energy certification wasn't rolled out to commercial buildings. If that had been done, the incentive would have been there for all of this data to already be in the public domain, like the US cities are doing. So I think we shouldn't underestimate the power in designing the right incentives, if that makes sense. So for my company to look at this data, to go back and revisit this building, there's a good business case there because we know from our clients, for example, that the existing legislative structure doesn't deliver the building performance that they're after. Their commercial models in relocating buildings or occupying buildings or building new, renovating their estate is all based on the maintenance cost model, at least for the more savvy ones. And if the energy consumption data doesn't add up, they're going to be losing money, and local authorities and other larger estate holders can't afford to do that, so they want a bit more certainty. And if you can verify that with the data that you have collected, and you can demonstrate that you understand exactly where people are going to pull the wool over your eyes when the building is going to be constructed, then that's a market advantage, and it's really obvious.
I'll give you two reasons why I think top-down may have seen its day. The first is, for precisely the El Salvador example, that if only 10% of our buildings are, if you like, designed top-down and 90% are emerging bottom-up, it's just the weight of where we have to go. And the second is that although somewhere like China, which does top-down immensely effectively and has demonstrated through its economic growth how effective top-down organization is, you have to question the result of that in terms of its effects on the people, effects on the environment, and so forth. And although one can aim to try and make top-down produce better quality, the history suggests that once an elite is in charge of top-down, the elite thinks mainly about the elite.
Do you not think, though, that that's mainly about because they stop having feedback? Because everything about creating the right incentives is about checking that there are what the unintended consequences are.
I think
once the feedback
that's
loop
absolutely
breaks,
right. The problem is when you have an effective top-down organisation, it does everything it can to eliminate feedback.
Agree. And I totally
Speaking as dean. Okay, any more questions? One more question from the floor, please. Oh, we have two hands. Okay, we'll take both.
I think it was very, very interesting, especially Judit. It was very interesting to see how you map these buildings and how we have lots of data right now. But what I was wondering, isn't it also very important to think, especially with individuals that are not involved in architecture or engineering, how you make them realize how to interpret this data? Because we have lots of numbers coming out, but if they don't really understand what it means and how they have to act, especially if you think bottom up, isn't that also very important that we think about that? And I was wondering what your thoughts were about this.
Can we take the second question as well and then handle it all in one go?
Well, my question's pretty similar. Do you ever worry that the data is justifying the ends but not really solving the problem? In other words, you get the energy efficiency of the building very well, you know, within whatever you were looking for, but everybody's uncomfortable in the building. You know, is that, do you see that as a problem, or is it just you're using the data, you know, the ends to justify the means, so to speak?
Judith, these are both for you.
I've got a few questions for you, though. So the first question was, so answer to that was, I think what's really, I am tremendously excited to be able to work with 3 NGD students, and in a way the group that we have set up with UCL, or Dayan and the Energy Institute have set up, it's amazing to see younger people adopt some of these ideas, and I'm absolutely delighted that you know, there's now consideration of setting up a building performance related course at UCL, which is very much a multidisciplinary. It's going to become a very multidisciplinary course if it does take off. And yes, I think, you know, doing things like CPD, so it's the literacy in the data which is really critical. So, you know, the and the recognition in the awards, like the RIBA is now asking for energy consumption data to be submitted as part of the awards. SIPSI does the same. More and more organizations are signing up to doing similar. The American Institute of Architects is doing the same. So, there isn't really that much that you need to understand. I think everybody can read an energy bar. So there is power in simple communication. And the second one was... Can
I come in on that? Yeah. Can I come in on that one? I'll come on that one to give you a minute just to think of the answer. So this idea of data literacy to me it's absolutely crucial, but it's not just for non-engineers and for non-architects. You know, I can show you loads of examples of energy data that I've had where the energy data is just wrong. The meter's being plugged in upside down. I don't know what it was, or the meter's only off by a factor of 100. I mean, these are insane, but these are systems that are recording data that are being logged into systems that have been running for years. And so it's this idea of, you know, data literacy around the trustworthiness of the data, the reliability of the data in those kind of cases, the trustworthiness of the data, kind of where that data is actually coming from, and, you know, is a temperature really relaying a correct temperature? So the kind of the provenance of this information. And, you know, to me, data, the reason why I like to say this term, and as we mentioned as well earlier on, this kind of data being a material, you know, data has properties like lots of other materials have properties, and you have to understand how to use it in the context of the environment in which you're trying to use that data. And to me, these are all skills that we have to teach. For me personally, this is why I'm focusing on schools, because if we can get kids working with data in a very natural way and understanding how to use and manipulate it, that's the best way forward.
Okay, we're getting close on time. Look, I'd like to thank the panel very much. Thanks for the presentations.